Today we're going to be looking at the factored form of a quadratic function. So by the end of this entire lesson, we will be able to write quadratic equations in factored form. We'll be able to use that factored form to identify the zeros, which is our fancy word for our x-intercepts, and also determine the intervals over which the quadratic function is positive and negative. So overall, the factored form of the quadratic function is used to find the zeros of the function by identifying the value that makes one or both of the factors equal to 0. The graph shows the function defined by y equals x squared plus 2x minus 8. How do the zeros of the function relate to the factors of the expression x squared plus 2x minus 8? So let's first identify what the zeros are. So zeros are the same as x-intercepts. So if we look at our graph, we have -4, 0 and 2, 0. So the question is saying, if we actually factor this expression, how do the zeros have something in common with the factors? So let's start by factoring. So I'm looking for numbers that multiply together to equal -8, and they add together to equal 2. So they multiply together to equal -8, and those same two numbers have to add together to equal 2. So if I have a negative with the product, that means that one of the numbers has to be positive and one of them has to be negative. That's the only way we're going to get a negative. And we also know that when the numbers are added together, the sum is equal to 2. So it's positive. So that means that the larger of the two numbers has to be the positive number. So +4 times -2 is -8. And 4 plus -2 is equal to 2. That works. So when we factor this, we get x plus 4, that's our first term, and then x minus 2, that's our second one. So now let's look at the zeros. So the zeros are -4, and we have a +4. And we also have a 0 of 2, and then we have a -2. The 0 of the quadratic, so the x-intercepts, are the opposite sign to the numbers that we find in our factors. And in the next example, we will talk about why.